to True Projects. In this video, we are going to explain about the project, which is performance evaluation of phishing classification techniques on various data sources and schemes. Introduction of the project. Phishing is a perilous threat to cybersecurity, and according to the National Institute of Standards and Technology, it attempts to get sensitive data such as bank account numbers or access to larger computerized systems by sending fraudulent requests through emails or websites. The corporate sectors include technology, energy or utilities, retail and financial services. These organizations are highly vulnerable to phishing. Traditional methods for evaluating phishing classification techniques often rely solely on accuracy, which may not provide a comprehensive assessment for their effectiveness in real-world scenarios. Machine learning techniques are essential in this project as they enable the evaluation of a wide range of classification methods and their adaptability to different dataset subsets, improving phishing detection. The project utilizes three datasets including MDP 2018, UCI phishing website, and UCI spam base to assess how varying dataset proportions impact the performance of classification techniques. Objective of the project. The primary objective of this project is to systematically assess and compare the performance of multiple phishing classification algorithms across diverse datasets and data subset schemes. The project aims to identify the most effective algorithm for phishing detection in various scenarios. To achieve this objective, the project utilizes a variety of classification algorithms including random forest, support vector machine, logistic regression, multi-layer perceptron, C4.5, Bayesian network, etc. The project's objective is to evaluate and compare the performance of these algorithms using various performance metrics including accuracy, precision, recall, and F1 score. The project aims to boost user interaction and accessibility by integrating the Flask framework, enabling the development of a web-based interface. This interface allows users to interact with classification algorithms, choose datasets and subset schemes, and visualize evaluation results, ultimately providing a user-friendly platform for exploring phishing classification techniques. To implement this project, we need hardware and software requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. To implement the project, we have designed various steps in the flow of work. The first step is importing the packages. This step involves importing necessary Python libraries and packages that will be used throughout the project. We have imported NumPy for numerical operations, Pandas for data manipulation, Matplotlib and Seaborn for data visualizations, and scikit-learn for machine learning. Exploring the dataset. Here we explore three datasets that will be used in the project. The first dataset is UCI phishing dataset. It contains features and labels that are related to phishing websites. MDB 2018 dataset. It likely includes features and labels to differentiate between phishing and legitimate URLs. UCI spam-based dataset. It contains features relevant to web-based threat detection. The features include attributes associated with email content and sender information. In this exploring the dataset step, we understand dataset structure, content, and characteristics. This is important for data pre-processing and model building. Data processing. This step involves preparing the dataset for analysis. It has two substeps. The first one is Pandas data frame. Here we create Pandas data frame to organize and structure the dataset. Pandas data frame provides a convenient way to work with tabular data, allowing us to perform various operations like filtering, sorting, and selecting specific columns. Cleaning the dataset. Cleaning involves identifying and addressing issues in the dataset that could impact analysis and modeling. This includes handling missing data, removing duplicates, and addressing inconsistent or erroneous entries, and ensuring data types are correct. Cleaning ensures that the dataset is in a suitable format for further analysis and model training. Visualization using Seaborn and Matplotlib. In this step, we use data visualization libraries like Seaborn and Matplotlib to create graphs, charts that help in understanding the dataset and its characteristics. Label encoding using label encoder. Label encoding is a technique used to convert categorical data into numerical values, making it suitable for machine learning models. Feature selection. This step involves selecting the most relevant features from the dataset to reduce dimensionality and improve model performance. Appending the feature column to X and target to Y. Here we separate dataset into feature columns as X and target column as Y, where X contains the input features and Y contains the target variable to be predicted. Splitting the data into train and test ratio, where the ratios include 90s to 10, 80s to 20, 70s to 30 and 60s to 40. These splits are used to train and evaluate machine learning models. Building the models. Various machine learning models are built in this step for all the three datasets, and the models used are random forest. It is an ensemble learning method that combines multiple decision trees to improve classification accuracy and reduce overfitting, making it suitable for robust phishing detection. SVM, which is support vector machine, it is a powerful classification algorithm that can separate data points using hyperplanes in high dimensional spaces, making it effective for distinguishing phishing from legitimate data. Logistic regression. It is a linear model used for binary classification tasks, making it simple yet valuable algorithm for phishing detection. MLP, which is multiple layer perceptron, it is a type of artificial neural network known for its ability to learn complex patterns, making it suitable for handling intricate features in phishing data. C4.5, it is a decision tree algorithm that can be used for classification, which can make it useful for understanding feature importance in phishing detection. Bayesian network. It is a probabilistic graphical model that can capture dependencies among features, aiding in probabilistic modeling of phishing likelihood. Rep tree, which is decision tree, it is a type of decision tree algorithm that is well suited for classification tasks, providing insights into decision-making process in phishing detection. Naive Bayes, it is a probabilistic classification algorithm based on Bayes' theorem, making it useful for model conditional probabilities in phishing classification. PART, which is passive aggressive random forest decision tree. It is a hybrid classification algorithm that combines passive aggressive learning with decision tree modeling, making it adaptable to evolving phishing threats. ABET, which is AdaBoost Extra Tree. It is an ensemble learning method that combines extra trees with AdaBoost, enhancing the performance of individual classifiers in phishing detection. ROFET, which is Random Forest Extra Tree. It is another ensemble method that leverages extra trees within a random forest framework, providing robustness in phishing classification. BET, which is Bagging Extra Tree. BET is an ensemble technique that employs extra trees with a bagging framework to enhance the performance and stability of the model in phishing detection. LBET, which is Logistic Gradient Extra Tree. It combines logistic gradient boosting with extra trees, aiming to improve the accuracy of classification models for phishing detection. Flask framework for SQLite for sign-up and sign-in. Flask, a web framework for Python, is integrated into this project to create a web-based framework. SQLite is used as a database for user sign-up and sign-in functionality, allowing users to access the system securely. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction, and we have built a front-end using Flask framework for user testing and with user authentication. User gives input as URL. User provides input in the forms of URLs, which will be processed and used for prediction. The given input is pre-processed for prediction. The input's URLs are pre-processed, likely involving feature extraction and encoding to make them compatible with trained machine learning models. Trained model is used for prediction. The pre-processed input data is fed into the trained machine learning models to predict whether the provided URLs are phishing or legitimate. Final outcome is displayed through frontend. The results of the prediction are displayed to user through the web interface created using Flask, providing a user-friendly way to access the classification outcomes. Comparison graph for UCI phishing dataset. This is the accuracy comparison graph. Accuracy is the proportion of correct predictions in a classification task, measuring the overall correctness of a model's predictions. Here in this graph, x-axis represents accuracy scores of each algorithm and y-axis represents algorithm names. This is the precision graph. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. This graph also contains x-axis precision score of each algorithm and y-axis contains all the algorithm names. This is the recall score graph. Recall score is also known as sensitive or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any instances. So, here also on the x-axis we have recall score of each algorithm, and on y-axis we have algorithm names. This is the f-score. F-score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced dataset. Here this graph also represents on x-axis F-score for each algorithm and y-axis represents algorithm names. Comparison graph for MDP dataset. This is the accuracy graph for MDP dataset. This is precision graph. This is recall graph. And this is F1 score graph. Comparison graph for UCI spam-based dataset. This is the accuracy score for UCI spam-based dataset. This is precision score for UCI spam-based dataset. This is recall score. This is F1 score graph. For execution of the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. It contains information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content that to be rendered in HTML templates. These two are the IPYNB files. These are the Jupyter Notebook files which contain a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. This is the sign-up file. This is the database file used to store the user information. Now we need to copy the path from the address bar of the file explorer, so I'm copying the path. And now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This command will change the current directory to the code folder's path. So here we need to type python space app.py. This will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost and the port. This is the localhost and this is the port. And now we need to copy this local link provided by the framework and paste it in any browser. I prefer Google Chrome, so I'll paste it in that. So here we'll paste the link and click on enter. This is the web page of the project which is displayed in the browser, and this web page is built by using the Flask framework. So here we can see a link which is sign up link. So first we need to click on this link, so I'm clicking on this link. Here we need to provide all the registration details if you are registering newly. I have already registered, so I'll directly click on sign. And here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password, and now we need to click on sign in. We have signed in successfully and we are redirected to phishing detecting page. Here we need to provide the URL, and then it will redirect to page where it will determine whether it is phishing URL or not. So here we will give the input as URL. So I'm selecting the first URL as the input. I'm copying it. And here we'll paste the link, which is URL. And now we need to click on check here. Based on the given input, which is URL, it is predicted that the website is 100% unsafe. If we want to still continue, then we can click on still want to continue link. So I'm clicking on this link. This is the web page URL. And now we will give one more URL. For that we need to click on home. And here we'll paste the URL. So I'm selecting this URL as the input. So I'm copying it. Here we will give the link. And now we need to click on check here. So it is predicted that the website is 87% unsafe. If we want to still continue, then we can click on still want to continue. so the website is unsafe. Now we will close this. And now we need to click on sign out. Conclusion of the project. The project conducted a comprehensive assessment of various machine learning algorithms for phishing detection, taking into account different datasets and data splitting ratios, ensuring a thorough examination. The inclusion of ensemble techniques, notably the stacking classifier, not only significantly improved model accuracy but also showcased potency of amalgamating multiple models for superior predictive performance. Through the seamless integration of Flask with SQLite, the project not only facilitated user-friendly interactions but also fortified user authentication, establishing a secure and user-centric platform for entering URLs and accessing phishing predictions. In addition to the outstanding technical accomplishments, this project contributes to valuable insights into the practical implementation of ensemble methods and web-based interfaces, greatly enhancing our understanding and application of cybersecurity measures.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.